Welcome to lesson A-18. In this lesson, you will continue to add to your new coding skills by working with physical inputs, learning more ways to use the time and random modules, trimming long numbers, and a new way to use the loop command. Later in the activities for this lesson, you will then use the skills you've gained over the last 17 lessons to create a two-player game. Let's get started. Now in this video, we will cover working with physical inputs. Specifically, we'll talk through the 3 states of physical inputs, electrical differences and configurations, and we'll look at an example circuit and the code for pulling the pins to determine if they're high or low. Then you'll move on to the next video to cover the other new skills you'll need to build the game in the activities portion of this lesson. Back in lesson A-16, we talked about GPIO pins, which stands for General Input Output. Of the 40 pins that are connected from the Pi to the breadboard, 22 of them can be assigned to be either inputs or outputs, and each input or output can be either low, which means no voltage available or ground, or high, which means 3.3 volts is available. When a pin is acting as an input, information is flowing from the breadboard to the Pi. We can use that input to pull a pin. That's when we ask the pin whether it's operating in a low or high state. When a pin is acting as an output, information is flowing from the Pi to the breadboard. A pin in a high state has 3.3 volts available for an attached component, and we call that driving the component. Remember back in the third video for lesson A-16, we went through how to set up our code so we could use the GPIO pins. And there were 5 steps. The third step was to add code that would assign the pins we would be using to be either an input or an output pin, depending on what we needed for our program. And then the fourth step was to use code to assign the output pins to either a high or low state. And by doing so, we're making them either having 3.3 volts available, that's the high state, or we're assigning them as ground, which is the low state, and they don't have any voltage available in that circumstance. But in the case of GPIO pins we've configured as inputs, we will assign them a default high or low state by using a high value resistor in the circuit. And for the rest of this video, I'm going to talk you through how to use resistors in your breadboard to change the electrical configuration of those input GPIO pins and assign the input pins to be either a high state or a low state as their default. Now, a quick note. It is possible to assign input GPIO pins as high or low using Python code, but that process is more complex, so we will tackle that in level B of this program. For now, we'll stick with the simpler option of using a high-value resistor. Okay, first let's talk through why you would even need to assign an input pin to be either high or low state as its default. In previous lessons, you learned about programs that can take input from a user in the form of answering questions and save those answers as variables in your program. So, for example, in the activities for this lesson, you're going to build a 2-player game that you can play. And instead of asking questions and having users input their answers by typing them into the program, the users of the game will press switches, and we will need to have our GPIO inputs and our program set up to interpret the input we receive from the switches being pressed. To interpret the information correctly, we'll need to assign the input pins we are using to be in the correct default state. So physical inputs like the GPIO pins have 3 states they can operate in. The first is low, and that means connected to ground. The next is high, and that means connected to positive voltage supply. In the case of the Raspberry Pi, that's 3.3 volts. And then floating means not connected to anything. High and low are the best options for an input because those states can be very easily identified by a program. A floating input should not typically be used because, just like the name, the voltage level of the input can float all over the place. And this causes the input to be read as high or low. It's very unpredictable, so you'll want to avoid that. So to configure an input GPIO pin for a high default state, we would need to create what we call a Pullup Resistor. This is when we use a high value resistor in the circuit to cause the default state of that GPIO pin to be high. So unless some other component comes along and shifts that pin state to low, we would expect that pin to operate in a high state. The next electrical configuration is a low state configuration. And so to configure a GPIO pin for a low default state, we would need to create what we call a pull down resistor. And this is when we use a high value resistor in the circuit to cause the default state of that GPIO pin to be low. So unless some other component comes along and shifts that GPIO's input pin's state to high, we would expect that pin to operate in a low state. All right, here is the third electrical configuration. It's called a floating configuration, and we talked briefly about this a few minutes ago. This condition is created when the input does not have a pull-up or pull-down resistor to set its initial electrical state. So this input pin will float up and down and can cause unreliable readings, so we want to avoid leaving a pin in a floating state. Okay, let's take a look at an example circuit from Activity 1 for this lesson, which you'll be working on a bit later. Hopefully this will help clarify why it's important to pull up or pull down the GPIO pins. In the circuit for the game you'll build, you will use pull-down resistors on two input GPIO pins that will cause those inputs to exist in a default low state. And then you'll add two switches that will pull up those inputs to high when you push the button on the switch. Okay, so let's walk through this diagram for the circuit. GPIO 20 and 21 are the inputs we're using for this project. They are in a default low state because we have used 10,000 ohm resistors as their pull down resistors. Once a push button switch is pressed, current will flow from the 3.3 volt power source through the 1K ohm resistor through the switch and into the input pin. And this will allow the program to register that the input is now high instead of its default low. So the program will recognize that the button has been pressed. Okay, now those 1K ohm resistors you see there are in place for each branch. So when the switch is pressed and the current flows, that current is limited so it doesn't damage the Raspberry Pi. Now, when it comes to GPIO inputs, it's important to remember that high is true and low is false, because we're going back to that logic, right? That logic code we worked hard to learn. So if you wanted to check if GPIO 20 is high, which remember is called pulling the pin, you would use something like this first code example. Or to pull the pin to see if GPIO 21 is low, you'd use the second code example. These types of input condition checks will come in handy when you start programming the game and the activities. Okay, before you move on to the next video, let's take a few moments and review the concepts we just discussed. First, of the 40 GPIO pins connected from the Raspberry Pi to the breadboard, 22 can be configured as input or output pins using Python code. Those 22 pins can be configured as high or low, and we do that for output pins using Python code, but we need to configure input pins using a high value resistor to pull the pin high or low. So remember, a pull up resistor sets the pin's default input pin's default state to high, and a pull down resistor sets the input pin's default state to low. Okay, if we don't pull an input pin up or down, it'll float, and its readings will be unreliably high and low, and so we want to always avoid having pins float. Next, we looked at an example circuit, which you'll be working with in activity number 1. And each branch of the circuit has a pull-down resistor in place, so the input is in a default state of low. But there's also a push-button switch. When pressed, the pin state will switch to high, and that change will be registered by the program and recognized as a button being pressed. And finally, we looked at the code we would need to pull or check a pin to see whether it's in a high or low state. We will use this during the activity to recognize when the buttons on the circuit have been pressed. Now that you know how physical inputs are configured, go ahead and move on to the next video for this lesson, where we'll talk through other ways to use random and time modules you've previously worked with, as well as talk about while loops, which will make it easy for us to pull that pin repeatedly so we can catch as soon as that button is pressed in the circuit.